Okay, so welcome to 209. Okay, so this is a video just for you. So in your past, can you think about what is a chemical equation? What must they have in order for them to be considered as a chemical equation? How are they different from word equations? So word equations are what you learn in primary school, like glucose plus oxygen gas gives you carbon dioxide plus water. Okay, so this is what you learn in primary school about word equations. So how are chemical equations different from word equations? Can you pause this video now and discuss with your friend? Return to this video after about 1 minute. Okay, so welcome back. I trust that you have discussed it with your partner. So what is a chemical equation to you? And what must they have in order to be considered as a chemical equation? So based on the responses that the other classes gave me, a chemical equation generally needs to have chemical formulas. Okay, so with a chemical formula, that alone is not sufficient for it to constitute a chemical equation. So for it to be a chemical equation, you must have some form of reactants giving you some form of products. Now what did I bracket the S is because it may or may not be just one reactant giving you two products, or it could be two reactants giving you just one product. Okay, there are various types of reactions that can take place, so that's why the plural form, can be singular, can be plural. Okay, so how are they different from word equation? So again, in word equation we use words. In chemical equation we use chemical formulas. So other than that, what is different is for chemical equations we need to balance the equations. Okay, whereas for word equation, note that for glucose I do not need to like 3 carbon dioxide times 2 water. We do not need to balance the atoms or the elements that's present on the left hand and right hand side. Whereas for chemical equations, we need to do that, okay, based on their chemical formula. So let's try and balance some chemical equations. So here I have a simulation. Okay, note what is N2, what is H2, and what is NH3. So N2 is your nitrogen gas, H2 is your hydrogen gas, and NH3 is ammonia. So at the start, let's assume that everything will have one of each. Not if there are 0, then we don't even need to write it in the equation, right? So assume that there's one of each of the species here. Okay, now let's calculate the number of nitrogen atoms on the left hand side. On the left hand side, I have 2 of the blue balls, 2 nitrogen atoms. On the right hand side, I only have 1 of the blue ball, which is nitrogen. Okay, so there's 2 nitrogen on the left, but only 1 nitrogen on the right. On the left hand side, I have 2 hydrogen atoms, but on the right hand side, I will have 3. So as you can see very clearly, the number of nitrogen and hydrogen both do not balance on either side. Okay, so how do I balance this equation? Very simple. I have 2 nitrogen on the left hand side, I have 1 nitrogen on the right hand side. So let's try increasing the number of nitrogen on the right hand side by 1 by multiplying 2 to the entire ammonia. Now note that when I multiply 2 to ammonia, the number of hydrogen atoms correspondingly will change as well to 6. So now that I have 6 hydrogen atoms on the right hand side, I have 2 hydrogen atoms on the left hand side. How can I make it such that the number of hydrogen atoms will balance on both sides? Okay, yes, so I need to multiply the hydrogen to 3. Okay, you see a smiley face, that means that it's correct. Now let's move on. Try to separate water. Okay, how can I do so? Okay, look at the number of hydrogen atoms, the white color balls. On the left hand side I have 2, on the right hand side I have 2. Now let's look at the number of oxygen atoms. On the left hand side I have 1, on the right hand side I have 2. So how can we balance this equation? Obviously I need to times 2 on the left hand side to water. Correspondingly, it causes the number of hydrogen atoms to change to 4. So now that I have 4 hydrogen atoms on the left hand side and only 2 on the right hand side, I need to multiply hydrogen gas by 2. Okay. Last example, I have methane added to oxygen gas, gives you carbon dioxide and water. Okay, now number of carbon atoms on the left hand side is 1. On the right hand side there's 1 as well, so carbon is balanced so far. Let's look at the number of hydrogen atoms. On the left hand side I have 4, on the right hand side I only have 2. Okay, then look at the number of oxygen atoms. On the left hand side I have 2, on the right hand side I have 3 in total. Now note that oxygen is present in more than one species on the right hand side. It is present in carbon dioxide as well as in water. So when that occurs, when a particular element appears in more than one species on either side of the equation, we try not to balance it first. That is because, for example, let's say I up my oxygen gas to 4. Then I do not know if I should up my water. Okay. This is an easy example lah. But I do not know if I should up my carbon dioxide or I should up my water to affect the change in my oxygen gas on the left hand side. So what I try to do, and it's also written as a tip down at the bottom of your worksheet, is that I try and balance the element that only appear on one species on each side. What do I mean? For example, carbon only appears in one species on the left hand side, which is in methane, and it only appears on one species on the right hand side, which is in carbon dioxide. So carbon is a element that I will try and balance first. Okay, in this case it's already balanced, so let's look at the other element, which is hydrogen. Hydrogen only appears in methane on the left hand side. It also only appears in water on the right hand side. It doesn't appear in carbon dioxide. So it's very clear to me. Now on the left hand side I have 4 hydrogen, so to balance the number of hydrogen, I can only change the number of water molecules on the right hand side. Okay, here then I have 4 of hydrogen atoms on each side. Then let's balance the number of oxygen. Okay, now that I know for sure that carbon hydrogens are balanced, let's look at the number of oxygen. On the right hand side I have 4. So on the left hand side I must have 4 as well by multiplying 2 to the oxygen gas. Okay, so this is it for the teacher's demo. Okay, then next I'll show you a concrete example. This is what you might see in the exam. First, you'll see a word equation. Magnesium hydroxide added to hydrochloric acid gives you magnesium chloride and water. Now hydrochloric acid is an acid that I have mentioned in the previous lesson. So you can check your previous notes. Can you write down all their formula first? Pause the video and write the formula of each of these species. Okay, so here's just for you to check your answer. Magnesium hydroxide is MgOH2, hydrochloric acid is HCl, magnesium chloride is MgCl2, water is H2O. Okay, so again, I'll ask you to pause and check if your formulas are correct, because if your formulas are wrong, obviously your chemical equation will also be wrong, since the number of atoms and all that is calculated based on the formula that you wrote. Okay, next. Write down the number of atoms on each side of the equation. Now what do I mean? Okay, so you split it down the center of the arrow. On the left hand side, we have 1 magnesium. We have 2 oxygen because these 2 belongs to both oxygen and hydrogen. So next, how many hydrogen do we have? I have 2 hydrogen atoms here and 1 hydrogen atoms here. So I have 3 hydrogen atoms and 1 chloride. Now, can you try to do the same for the right hand side? Okay, so we have 1 magnesium atom on the right hand side, 1 oxide, 2 hydrogen, and 2 chloride. So did you count the number of atoms correctly? Now next, we look for elements which have different number of atoms on each side. We balance by multiplying the species. Okay, so if we look here, you can see that oxygen, hydrogen, and chloride all do not have the same number of electrons on either side. So, can I ask you, what will you start with? Will you start with hydrogen? Okay, why or why not? Okay, you should not start with hydrogen because you can see that hydrogen appears on both magnesium hydroxide as well as hydrochloric acid on the left hand side. So you do not know which of them to change to make that the other side equal. So what I arbitrarily tried to do is between oxygen and chloride, you can choose either one. Okay, what I decided to do is choose oxygen since it's at the top. Okay, so multiply the oxygen containing species on the right hand side by 2 because currently oxygen on the left hand side has 2, oxygen on the right hand side has only 1. So let me multiply that species, which is water. So you know that when I multiply water by 2, I not only affect the number of oxygen atoms, I will also need to update the number of hydrogen atoms on the right hand side. So now that oxygen is satisfied, you can see that hydrogen is again not satisfied. Okay, but we ignore it first and we go for the chlorine because it is easier to balance chlorine since it only appears once on each side. Okay, so multiply the chlorine containing species on the left hand side by 2. We'll multiply by 2, again the number of hydrogen will be affected. Okay, so pause and check. Do you remember to change the number of hydrogens as well? Okay, so when all the elements have the same number of can, but I need a while, 5 minutes more.
Of what?
I'm recording something.
5 minutes. Okay.
Okay, sorry for the interruption. Okay, so let's just look at this equation. You can see that the elements on both sides are balanced already. So this is the chemical equation that you have at the end. Now, these are all the steps that you need to take when balancing an equation. Remember to always pause and check. So, can you go to the simulation game and try to balance the equation? Try all levels 1, 2, and 3. You can go and Google PHET simulation chemical equations. And then press the play button. Okay, and that's all. Try and finish the further practice that I gave in the worksheet. So please also do the assignment 1, page 1 and 2, and hang into your chemistry lab by Friday. Okay, that's all from me. Thank you, class.